Hello, and welcome to this pre-recorded event for feedback on the June 2015 GCE Mathematics Examination, Decision Mathematics 1. To help you get the most out of this feedback, you may wish to have the following documents handy, as they will be referred to during this session. You will need a copy of the unit specification for cross-reference of the topics discussed during the feedback session. You will also need a copy of the D1 June 2015 question paper and mark scheme. These will be of particular use later, when each question from last year's examination is discussed in detail. You will need a copy of the 2015 Principal Examiner's Report for D1, which should be read in conjunction with the feedback given in this feedback session. Finally, you may find it useful to have a copy of the D1 May 2013 question paper and mark scheme. These may be of particular use when marked candidates' responses are considered towards the end of this pre-recorded event. The key aims and objectives of this training event are detailed in this slide, and it is hoped that all these aims and objectives are clearly and concisely covered in this training pack. The AS Unit D1 contains the following topics: algorithms, algorithms on graphs, the root inspection problem, critical path analysis, linear programming and matchings. Candidates need to be familiar with the material in and the glossary attached to the D1 specification. The examination will consist of one 90-minute examination. The paper will contain about 7 questions, with a varying mark allocation per question, which will be stated on the paper, and all questions should be attempted. In particular, this unit will develop an understanding of mathematics and mathematical processes in a way that promotes confidence and fosters enjoyment. It will extend the candidate's range of mathematical skills and techniques, and use them in more difficult, unstructured problems. Finally, this module will allow candidates to recognize and develop an understanding of how a situation may be represented mathematically, and give an understanding of the relationship between real-world problems and standard and other mathematical models, and how these models can be refined and improved. The number of candidates for this unit has once again increased, and in June 2015, 24,218 candidates sat this examination, which represents an increase of 4% on the number who sat the examination in June 2014. Further details are given on this slide with respect to the mean and standard deviation for the June 2015 paper, the minimum mark required to achieve each grade, and the percentage of candidates who were awarded a grade A and the percentage of candidates who were awarded a grade E or better. It can be seen from this slide that the number of candidates for this unit has increased year on year. Furthermore, in June 2015, the mean for this unit was slightly lower than in June 2014, although the standard deviation stayed almost the same. Finally, the percentage of candidates achieving a grade A increased by just over 1% on 2014, although the percentages gaining a grade E saw very little change when compared to last year. Comparisons between the percentage of candidates achieving a grade A and E for this applied module, and those for the other two applied modules, Mechanics 1 and Statistics 1, can be seen on this slide. As a general introduction to the candidate's performance on the D1 examination for 2015, it should be noted that the majority of candidates demonstrated sound knowledge, and the paper proved to be accessible to nearly all candidates. Most candidates were extremely well prepared for the exam, and very few blank responses to questions were seen by examiners. It was clear that there were sufficient questions to engage the E-grade candidates, but also enough for Grade A candidates to show their ability. Most candidates were able to produce well-presented solutions, making excellent use of the tables and the diagrams given in the printed answer book. Candidates need to be reminded that they must use methods of presentation that do not depend on colour, but are advised to complete diagrams in dark pencil. Candidates are further reminded that this is a methods paper, and they must make their method clear. Spotting the correct answer with no working rarely, if ever, gains any credit. Finally, candidates are reminded to use technical language and terms correctly, which this session was a particular problem in Question 3, Part B, and Question 4, Part A. You will now need access to the D1 question paper and corresponding mark scheme for June 2015. Question 1 was answered very well by candidates, as indicated by the fact that the modal mark was full marks, and this mark was obtained by just over 40% of the candidates. In Part A, candidates were asked to explain why the maximum matching algorithm needed to be applied twice, and it was expected that candidates would give an answer based on the simple fact that there were two unmatched vertices in each set. The most common incorrect answers were from those candidates who either stated or implied that there were only two unmatched nodes, or that there were two sets of unmatched nodes. In Part B, the majority of candidates could correctly find at least one of the two correct alternating paths, although some repeated the path stated in the question. Also in Part B, instead of simply stating the alternating paths as requested, many candidates changed the status of their alternating paths and stated the corresponding improved matchings. None of this additional work was necessary, and must have been incredibly time-consuming for the candidates. The vast majority of candidates in Part C correctly stated the improved matching associated with the given alternating path, although some did not include the unchanged matching of C with 4. In Part D, many scored both marks, although there are still a significant number of candidates who are neither stating nor showing their change of status. It is acceptable for candidates to either show the change of status by interchanging all of their connected symbols, or by writing change status. Candidates are further reminded that this is a methods paper, and for questions where a particular method has been asked for, if the final answer appears with no method shown, no marks can be awarded, even if the final answer is correct. Finally, if candidates are going to draw either their improved or complete matching, then they are reminded that examiners can only accept diagrams with exactly the correct number of arcs. If a candidate makes a mistake, then they must either draw the diagram again or list their matching. Question 2, which incorporated the topics of quick and bubble sorts and binary search, provided a good spread of marks, and once again, the Mödl mark was full marks gained by over 2/5 of all candidates. The majority of candidates, when performing the quick sort in Part A, used middle right pivots and were able to carry out the sort correctly. Errors occurred in the ordering of sublists after the first pass. For example, the 48 and 42 were often interchanged after the first pass. It was common for the 27 not to be selected as a pivot for the fourth pass, and many candidates failed to acknowledge that the sort was complete. With regards to this last point, examiners require that candidates either explicitly state that the sort is complete, or they should choose each item in the list as a pivot, or they should rewrite the final list. There were far fewer candidates this session who only considered one pivot per iteration, and while the question explicitly asked for the list to be sorted into ascending order, a significant number sorted into descending order, but then did not go on and reverse their list at the end. In Part B, candidates were required to perform a bubble sort on a different set of numbers, and the vast majority did this correctly. However, the question explicitly said that candidates needed to only give the state of the list after each pass, but far too many candidates showed each comparison and swap during the first and sometimes all passes. This would have been expensive in terms of time. There were occasional errors, including the loss of one or more items from the list, and examiners commented on the alarming frequency in which the number 77 appeared before the 75 in the final sorted list. Finally, in Part B, it was common for candidates to stop after a fifth pass, due to the list appearing to be in the correct order. Candidates are reminded that if a swap occurs during a pass, leaving the list in the correct order, but before the final two items in the list have been considered, then either they need to state that the list is sorted, or they need to make an additional pass through the list. Part C was done extremely well, with many candidates correctly applying a binary search to the list of 20 numbers. Most candidates correctly identified middle right pivots, and then went on to reject the correct sublist, which included the pivot value. However, a significant number of candidates continued to use a rejected pivot in subsequent passes. The use of a pivot in subsequent passes is referred to as a sticky pivot in the published mark scheme. Candidates are strongly advised to make their choice of pivot clear at each stage, and to rewrite the new sublist which is going to be used in the next pass. Finally, at the end of the search, candidates are required to make it explicitly clear that the item being searched for has been found. This can be done by stating that the search is complete, or the required item has been found. Examiners commented that many candidates did not differentiate the 68 in the list with the item that they were searching for, and in many cases, this value seemed to be stated as a pivot and not the target value. This question on Dijkstra's algorithm proved to be a good source of marks for most candidates, although only 7.5% of candidates achieved full marks. Part A was done very well, with many correctly applying the algorithm. The most important point to note when applying this algorithm are the working values at each vertex. If the algorithm is applied correctly, then the working values will not only be correct, but they will also be in the correct order. With regards to these working values, examiners need to be able to read these values, and therefore candidates are once again reminded that they should not be crossing these out. While a number of candidates had both the working values and corresponding final value at each vertex correct, a significant number did not have the order of labelling correct. Candidates would be advised to check that their order of labelling forms the arithmetic sequence 1, 2, 3, 4, with no number missing or repeated. It should also be noted that once a node has been given a final value, then no further value or values should appear in the working values at this vertex. Most candidates correctly stated the shortest route and corresponding length based on their application of the algorithm. Part B required candidates to explain how they determined the shortest route from their labeled diagram. The majority who gave a general explanation scored at least 1 mark for an indication of working backwards through the network. For the second mark, it needed to be clear that the shortest route was determined by working backwards from J, including an arc, if the difference in final values is equal to the weight of the arc. The second equally valid way of answering this part was to explicitly demonstrate the required calculations. The candidates who opted for this latter option were generally more successful. In Part C, very few candidates scored either of the 2 marks, and only the most able realized that the shortest route to E from A could be found by working backwards from E using their labeled diagram in Part A. This question on the route inspection algorithm proved to be a good source of marks for most candidates, with almost 9 out of 10 candidates scoring 9 or fewer marks, but only 1.2% of candidates achieved full marks. In Part A, candidates were asked to explain why a network cannot have an odd number of nodes of odd valency, and nearly all candidates found this to be the most demanding part of the paper. Very few candidates could articulate that for any network, the sum of the order of the nodes is equal to twice the number of arcs. Therefore, the sum of the order of the nodes must be even. If the sum is even, then there must be an even number of odd nodes. Part B was nearly always answered correctly, although an answer of A and H was occasionally seen by examiners. Apart from those candidates who forgot that an additional arc had been added to the problem, and so inferred that the network only contained 2 odd nodes, the vast majority stated the correct 3 distinct pairings of the correct 4 odd nodes. While errors did occur in the subsequent arithmetic, it is disappointing to note that many did not correctly state the arcs that needed to be repeated. Many stated that AE, rather than the correct AC and CE, should be repeated. While the majority correctly added the additional arc AB to Part C, it was subsequently forgotten in Part D, and so many gave the answer of 2,410 rather than the correct answer of 2,540 for the length of a possible shortest inspection route. Part E was done extremely well by the majority of candidates, with many realizing that BE had to be repeated, which would lead to a difference in the route lengths of 190. While most gave the finish point as D, a significant number gave an answer of B or E. Finally, while many had the correct method for answering this part, there was a disappointing number of candidates who did not answer the question which explicitly asked for the difference in the two routes. Question 5 proved to be a good source of marks for most, with the modal mark being 7 out of 10, scored by almost a quarter of candidates. However, less than 1 in 20 achieved full marks. The vast majority of candidates in Part A listed all the arcs from the network in ascending order of weight, and then made it explicitly clear which arcs were subsequently added to the minimum spanning tree. When applying Kruskal's algorithm, it is vital that candidates make it clear to examiners which arcs are being rejected, and when these rejections are taking place. Most candidates correctly applied Prim's algorithm in Part B. However, some listed the nodes rather than the required arcs in order. It is still disconcerting that a significant number of candidates are rejecting arcs when applying this algorithm. Most had the correct weight in Part C, with mistakes usually following on from earlier mistakes in either Parts A or B. It is worth highlighting that the weight of the minimum spanning tree is a constant for each network, irrespective of the algorithm used, and this should have been spotted by candidates who had two different weights, or trees, in the first two parts of this question. Part D was answered poorly by the vast majority of candidates, and many left all three parts to D blank. Very few candidates in Part 1 showed an understanding that the sum of the order of nodes is equal to twice the number of arcs, which would give an answer of m/2. In Part 2, candidates seemed more knowledgeable about the fact that the number of arcs in a minimum spanning tree is one less than the number of nodes, which therefore meant that the answer in this part was n-1. When the first two parts of D were answered correctly, it was common to see a strict inequality incorrectly linking the two answers in Part 3. Question 6 discriminated well, with the modal mark being 9 out of a possible maximum mark of 13, and with just over a quarter of candidates scoring 4 marks or fewer. However, only about 1 in 20 candidates scored full marks. In Part A, the majority of candidates drew the required lines correctly, although some were unable to draw the lines either sufficiently accurately or long enough. This slide also gives general advice on drawing lines in this type of question, and further details can be found in the Principal Examiner's report. The first of the two most common errors in this part was to incorrectly draw the line y equals 4x, rather than the correct 4y equals x. The second was to not show the line x equals 8, as distinct from the other three lines in any way. Candidates either failed to notice, or they simply ignored, the strict inequality that x was less than 8. If Part A was answered correctly, then candidates usually determined and labelled the feasible region correctly in Part B. In Part C, the majority of candidates drew a correct objective line, although it was common to see a line with the reciprocal gradient, or no line drawn at all. Candidates are advised to draw the objective line from an integer value, on one axis to an integer value on the other axis whenever possible. Finally, in this part, candidates needed to use the correct pair of simultaneous equations to find the optimal vertex of the feasible region, as it is neither accurate nor indeed correct to simply approximate these coordinates by reading off the graph. Those candidates who answered Part C correctly nearly always went on to score the mark in Part D. Parts E and F were often left blank, and many who did attempt Part E gave an answer of 8, 8, even though this point was not in the feasible region. A number of candidates incorrectly gave the coordinates as non-integer values, even though the question explicitly stated that an integer solution was required. Finally, in Part F, many could not handle the given inequality, and therefore it was common to see the incorrect answer of k equals either 1/4 or 5/3. This last question was a good source of marks for many, with over 15% scoring full marks, and only around 1/4 scoring 6 marks or fewer. Part A was handled well by the majority of candidates, with many correctly adding the 3 missing activities and the single dummy to their activity diagram. Occasional errors included the absence of some or all of the arrows that needed to be added to the additional arcs. Or, more worryingly, many candidates added additional events to their diagram. In Part B, the forward pass was generally completed correctly, with very few errors occurring. The backwards pass in Part B was handled less well, with the most common error being a value of 8 rather than a value of 13 at the end of Activity B. Candidates are advised to check these values carefully, as a significant number of subsequent marks may be at stake later in the question. Most candidates had the correct calculation to find the lower bound in Part C, although some tried to argue the minimum number of workers based on scheduling the workers, even though a calculation was explicitly asked for in the question. In Part D, candidates were asked to schedule the workers, and a number either left this part blank or produced a Gantt chart. In this final part, the most common error amongst those who did schedule was with Activity G. Many candidates did not have this activity taking place after Activities B and C. And furthermore, it was common to see this activity taking place before Time 8. Finally, candidates are advised to check their diagram, so that activities do not start before their earliest start time, or continue beyond their latest finish time. They should also check that the duration of all activities is correct. Also, for each subsequent activity, the immediately preceding activities must be observed and correct. Finally, all activities should appear once and only once. What follows are 3 marked examples of candidates' responses to a number of topics from the D1 unit. All 3 marked examples are taken from the May 2013 D1 paper. The first example looks at a response to the question on matchings. The question can be found on this slide. You may wish to pause the recording for this and subsequent slides to allow yourself sufficient time to familiarize yourself with the content of these slides. This slide contains the published mark scheme for this question. The candidate's response to this question appears on this slide. The marks awarded to the candidate with appropriate commentary are given on this slide. The second example looks at a candidate's response to the question on Dijkstra's algorithm. The question can be found on this slide. This slide contains the published mark scheme for this question. The candidate's response to this question appears on this and the next slide. The marks awarded to the candidate with appropriate commentary are given on this slide. The final example looks at a candidate's response to the question on the route inspection algorithm. The question can be found on this slide. This slide contains the published mark scheme for this question. The candidate's response to this question appears on this slide. The marks awarded to the candidate with appropriate commentary are given on this slide. Thank you, and we hope that you have found this pre-recorded event for feedback on the June 2015 GCE Mathematics examination for Decision Mathematics 1 both engaging and useful in your future teaching of this unit.